Section 5 of Chapter 4 deals with solving quadratic equations again. Before we solved them by factoring. Sometimes we learned though that we can't factor those equations. So we're going to learn today how to solve them by using square roots and finding the square roots of an equation. We start with the definition of a square root. A square root is the number multiplied by itself to get a square. And you should have dealt with these before, so quick example, square root of 4 is 2, because 2 is the number that's multiplied by itself to get 4, which is the square. So we call this square root of 2, we call the symbol a radical sign. A radical symbol, and the whole thing, the square root of s, is called a radical. So when I talk about a radical, I just mean that square root. And the number under the radical sign is the radicand. So you may want to jot those terms down in your notes. With square roots, there are certain properties that we can use, and you'll want to know how to use those. The product property simply says that if I have a product under a square root, I can split that up, and I can say the square root of one number times the square root of another. And sometimes that's important when we're manipulating the numbers. The quotient property simply says that if I've got a quotient of two numbers, I can split that up as well. The square root of A divided by the square root of B. As we're going, your final answer needs to, as always, be simplified. You know that a square root answer is simplified if there are no perfect squares under a radical sign. All right, if there are no perfect squares under a radical sign, that's your first step. The second step is there can be no radicals in the denominator. So if you've got perfect squares are all out of the radical sign and radicals are out of your denominator, then you know that you're simplified. So you probably have done some square root work. So let's just go quickly through the first few examples just to make sure that we're all on the same page. And I want to show you a quick with 75. You might recognize what comes out of there, but I'd like to show you quickly. If you use a factor tree on any of these, anything under a radical will work this way. If you use a factor tree and say, oh, 75 is 3 times 25, and 25 is 5 times 5. So I know that you saw, oh, 3 times 25 and 25 is a perfect square. But let me show you what it looks like when you put it under the radical. So 3 times 5 times 5. So 75 is the same as 3 times 5 times 5. If you see a pair of prime factors, or even if they're not prime, a pair of factors under the radical, then that is a perfect square, and that can come out. And it comes out as the 5. And the square root of 3 is not a perfect square, so it has to stay under. So 5 square root of 3 is the square root of 75. And you would just leave your answer like that. Same thing here. 7 times, or square root of 7 times the square root of 35. We can use our product property to say, well, that's the same as if I just take 7 times 35 under that same radical sign. And I knew 35 is 7 times 5. And there we have a pair of numbers that can come out. So 7 times the square root of 5 is our simplified form of that. Square root of 100 divided by 169 is the same as the square root of 100 over the square root of 169. The square root of 100 is obviously 10, and the square root of 169 is 13. So 10/13 would be your final answer at that point. Breaking them up comes in handy when some will come out and some will not. The square root of 11, there's nothing you can do with that. There's no prime factors that are perfect squares in there. The square root of 144 is 12, because 12 times 12 is 144. So the square root of 11 over 12. Now in all of these, we've checked to see there's no radicals in the denominator, and in these, they came out to be perfect squares in the denominator, so it was no big deal. But sometimes there's a square root, there's a radical in that denominator. What happens then? Well, in that case, we have to do what's called rationalizing the denominator. To rationalize the denominator, that simply means we want to get the denominator to be rational. So we want to get rid of the square roots in the denominator. We can do that one of two ways, depending on what we have in our denominator. If the denominator is simply a square root, then we multiply by that same square root, because the square root of something times the square root of the same number is just that number. So that simplifies that easily. Let's do an example like that. The square root of 2 over 15 is the same as the square root of 2 over the square root of 15. Well, 15 is 3 times 5, and there's nothing perfect squarish about that. But if I took the square root of 15 times the square root of 15, that would just be 15, which would be great because I would get rid of my radical in the denominator. You say, well, Mrs. Horning, you can't just multiply willy-nilly, and you're right. If you multiply the denominator by the square root of 15, you can multiply the numerator by the square root of 15, and by doing that, by multiplying by a number over itself, you're simply multiplying this fraction by 1. And if you multiply any fraction by 1, you haven't changed the value. So you can multiply the numerator and denominator by the same thing and not change the value at all. So then you multiply straight across. The square root of 2 times the square root of 15 is the square root of 30. And this would be your rationalized or simplified answer, square root of 30 over 15. All right, but what if you have something that looks like this? Now, if I multiply on the top and bottom by the square root of 2, that'll help this part. But remember, we have to multiply everything by everything. So then we'll have 5 times the square root of 2. Well, that doesn't help us at all. So what we're going to do is we're going to go back to the concept of the perfect square minus a perfect square. And we're going to multiply by the conjugate. The conjugate is a plus the square root of b. The conjugate of a plus the square root of b is going to be a minus the square root of b. The reason this works is because of our perfect square, because of our a squared minus b squared equals a plus b times a minus b, because the middle terms are going to drop out. Watch this. So the conjugate of 5 minus the square root of 2 is going to be 5 plus the square root of 2. Whatever we do on the bottom, we got to do on the top, so let's put it up there so we don't forget it. So in our denominator, 5 times 5 is 25. The 5 times the square root of 2 is 5 square root of 2. Negative square root of 2 times 5 is negative 5 square root of 2, which means those middle terms drop out. So then we just take negative square root of 2 times positive square root of 2 is just minus 2, because the square root of 2 times the square root of 2 is the square root of 4, which is 2. So 25 minus 2 in our denominator, which is 23. And so now when we multiply our numerator, you got to take 4 times 5 is 20. And 4 times the square root of 2 is just 4 square root of 2. So our numerator can't be simplified any more than that. That is our final answer. So our simplified fraction now becomes 20 plus 4 square root of 2 all over 23. Now the reason that's going to be handy is because we want to actually solve. We're finally getting to solving the equations. So let's give you an equation to solve. 2x squared minus 15 equals 65. And if you'll look, there's no perfect square, or there's no, the 2x squared is not a perfect square, so we can't have a perfect square minus a perfect square, and there's no middle term, so we're not going to be able to factor. So what we're going to do is, we want to get this to a point where we can just take the square root and find one final answer. So we want to get the x squared by itself, so we're going to add 15 to both sides. So 2x squared equals 60, 70, 80. We still want to get the x squared by itself, so divide by 2. X squared equals 40. X squared is 40, so if I want to know, well, what did I multiply by itself to get 40? I'm just going to take the square root. The square root of x squared is x. So if I take the square root of, remember, whatever you do on one side, you got to do on the other. So the square root of x squared is the same as the square root of 40. Now, the only thing I haven't shown you is if you have the square root of 40, let's just do it with 4 real quick. The square root of 4, you can multiply 2 times 2 to get 4, but you could also multiply -2 times a -2 to get 4. So anytime you take a square root, you're going to end up with 2 answers because you could possibly have a positive and you could possibly have a negative. So the way we're going to mark this is we're going to say plus or minus the square root of 40. So using this plus or minus sign, that actually is giving 2 answers. I'm giving a positive square root of 40 and I'm giving a negative square root of 40. So the solution to this would still, remember we said with the next squared term, we're going to have 2 final answers. There indeed we have 2 final answers here. Let's do one more, a little bit more complex, because you know I like to get a little bit harder and harder as we go. All right. The next one we have is 1/3 times the quantity x minus 4 squared equals 11. And we want to find out, well, what on earth is x? So in this case, once again, we're trying to get this x by itself. So the first step in doing that is going to be to undo this part. Well, that's easy. You just multiply by 3 on both sides, because the 3's will cancel, 3 over 1. So now we just have x minus 4 quantity squared equals 33. So now in this case, we would love to add that 4, but we can't because it's inside those parentheses and we have to undo the whole thing. So we have to undo the squared first. And the way you undo a squared is to take the square root of it. All right. So now we have the square root of x minus 4 squared is just x minus 4. So x minus 4 is going to equal, now remember, we took the square root of this. The square root now is positive or negative square root of 33. So x minus 4 equals a positive or negative square root of 33. Now we just add the 4 to both sides. So x equals 4 plus or minus the square root of 33. So far, so good? All right. Let's see. Let's have you do one more, and then I'll bring out the word problem, because you know that's what I like to do. Let's do this one. All right. So using what we just did, I want you to pause it, I want you to solve it, and then I want you to come back and see if you get the same answer that I do. All right? Solve it first. Okay. Now hopefully you already solved it. Now you're back. So what we're going to do is first we look to see, we've got to get rid of the 3. So this time we're going to divide by 3 so that these cancel out. So we have x minus 2 quantity squared equals 40 over 3. Now we want to get rid of the squared term, so we're going to take the square root. And remember, that's positive or negative, so plus or minus the square root of 40 over 3. So now x minus 2 equals plus or minus the square root of 40 over the square root of 3. What are we going to do with that? So now we need to add 2. So x equals 2 plus or minus the square root of 40 over the square root of 3. So don't you suppose you need to rationalize the denominator? So we're going to multiply by the square root of 3. So if you multiply the square root of 3 over square root of 3, you're going to get 3. Not the square root of 3, just 3. Oh, shoot. So we've got x equals 2 plus or minus the square root of 120 over 3. And then is there a perfect square in that 120 that I missed? That's what I missed. Let's do it. 120 has a 4 in it, which is a perfect square. So 4 times 30. So let's take that out. So x equals 2 plus or minus. The square root of 4 is 2. So we're going to have 2 times the square root of 30 all over 3. And probably it would have been easier if I had taken that 2 out here, but you'll see that it really doesn't matter. You can do that anywhere in the process. So 2 plus or minus 2 times the square root of 30 divided by 3 is your final answer. All right. Now that we know how to solve them, let's use them in a real life situation. Here we go. Quick. You need to know, in order to solve this type of problem, that the dropped object formula. The dropped object formula says h equals negative 16t squared plus h sub 0, where h is the height in feet, t is the time in seconds, and h sub 0 is the initial height, where you started out. Okay, so what we're going to do is let's use this information to solve this problem. Whew. All right, one thing you need to know about this dropped object formula, this only works on Earth. So if you go to the moon, sorry, this one's not going to work. If you drop an object off the roof of a building 240 feet tall, how long will it take the object to reach the ground? So we're going to use our formula. H equals negative 16t squared plus h sub 0. Let's fill in what we know. The t is the time, and that's what we don't know. That's what we want to find out. So negative 16t squared is the unknown. Let's see, the initial height of the building is the 240. Yes. So we're going to add 240 to this. And the height is where we want to end up. So if you drop an object off the roof, how long will it take to hit the ground? So the ground is at 0. So we want it to equal 0. So we simply want to solve for t, get the t by itself just like we did before. So subtract 240 from both sides. So let's swap it around just so that we've got the t squared on the left-hand side, because that's just easier for us to see. So negative 16t squared equals negative 240. We're going to divide by negative 16. Negative divided by a negative is a positive. 240 divided by 16, and I should be able to do that in my head, but I did it already on paper, is 15. And so t squared is now the square root of t squared is going to be the square root of 15, because we want just the time. We don't want time squared, obviously. So the time is plus or minus the square root of 15. Well, now, once again, we're dealing with a word problem. Can you have negative time? Not yet. We haven't traveled in time yet. So we can't use the negative time. So it's going to be the positive square root of 15. So here's where you just pull out your candy dandy little calculator and plug in the square root of 15. The square root of 15 is 3.9. So your time is 3.9 seconds. So that's how you work a dropped object problem. I think we've covered everything that you'll see in your assignment. I will see you soon.